All right, good afternoon, everybody. Welcome back to another live stream. I'm going to be completely honest. It's way too nice outside here in Bloomington today, so I'm honestly regretting scheduling this at this time now, knowing how nice it is outside. So today might be shorter. I don't have that much content to cover, but I know me. I always end up yammering on about something for a while. So hope you've all had a good Sunday so far. So we are in part 2 of our OpenTelemetry tutorial stream. So we'll begin today with a brief covering of what we covered in part 1, and then we'll jump into the part 2 content. And as always, all of these streams are recorded and available at least on YouTube. I know they're persistent on YouTube. They might be persistent on LinkedIn as well. I noticed that X rolls them off after about 60 days or so. But if you ever want to watch any of these replays, they're available on YouTube. Also, if you are watching live, I am taking questions on LinkedIn or YouTube as well, so feel free to pop those in the chat. So let's go ahead and cover a recap of what we did in part 1. So with part 1, we did a basic introduction of OpenTelemetry. And so as you can see here, this is my GitHub repo that you're welcome to go and reference. I put in some notes in the README here about what we're building, what we're doing, very much replicative of like what we're doing in the live stream content. Excuse me, the live stream content. Oh my gosh. Started to choke on my Sprite there a little bit. And so we covered things like what OpenTelemetry is, what these different various signals are. Now, one thing that I did fail to kind of mention yesterday or in the previous stream is that when we were actually applying these signals to the pizza API that we'll cover, or that we are covering, and I'll give a quick recap of that in here in a minute. What I failed to mention is a specific term that we use there. So when we actually apply to our code, like what sort of traces or logs or metrics we want to capture, we refer to that as instrumenting the script. And I hope that kind of makes sense. If you think about that from like I'm not a pilot, but like when I think instrumentation, I think like flight instrumentation. So if somebody's flying a plane, naturally they need to know the various all the different things that each of the gauges kind of say to have a safe flight. So it's kind of the same idea with instrumentation and OpenTelemetry. Is the whole reason that we're capturing these log spans, traces, metrics is that we are wanting to ensure that our application is running the way that we are expecting to over time from a variety of different perspectives. And again, I'm not necessarily going to recover what all those different signals are. And so what are we building with this? So we are actually building, and I'll cover the code here in a second, we're building a very simple Python API. It's actually a fake pizza order taking API. So imagine basically like if we were a pizza company or a pizza restaurant or even a local mom and pop shop, and we wanted to build an API that could take orders, that's what that API is doing. And actually, let's go ahead and just jump into that code here really quick. So this is the code that we wrote all last time. This is nothing new, particularly if you watched the last stream. Basically, we have all these different pieces of code, and so you can see here that we got a number of different endpoints that we are calling. The primary endpoint here, of course, is this post endpoint, which actually takes in the orders. And so most of this API here that we built was, in terms of like the business functionality itself, relatively light. And excuse me. And then in terms of the OpenTelemetry stuff, we intentionally went above and beyond. So you can see here with our OpenTelemetry setup, we set up a bunch of different metrics here, or meters that we want to capture metrics. So things like how many HTTP requests there were, how long the HTTP request lasted in milliseconds, number of orders, et cetera, et cetera. And there's so much OpenTelemetry code in here that it actually outshines the number of code here, or the amount of code here that actually represents the business functionality of the API. And so one thing that I touched on in the previous stream, and I would definitely want to touch on here again, is that whenever you're actually applying OpenTelemetry to something like a Python script, it's almost never going to be the case where your actual OTel code is going to outweigh however much like business code you need. And it's just going to depend on what you need. So with here, we went overboard, and that's intentional. We went overboard because we want to be very intentional about understanding what each of these pieces does with a bunch of different examples. It's going to be up to you on what sort of traces you want to capture, what sort of logs you want to capture, how many metrics you want to capture. And in that case, and again, because this is a very simple Python API, like we're not actually reaching out to some sort of backend database that's actually storing the orders over time or anything like that. And so that's why we have an abundance of OpenTelemetry code here. But in your real application, chances are you're probably not going to have that much OpenTelemetry code. Okay, so in terms of the pizza order taker itself, so we have we're capturing the trace here as a span, and it's doing a couple different things just as a reminder here. So we are normalizing the order. So by normalizing the order, we are taking in the order as a raw input and then making sure that it's all the stuff is appropriately cased, like lowercase and such. So that's what normalization is doing. We're calculating the price of the pizza. So we have a fake menu over here represented by this JSON. Very, very, very simple. In fact, let me blow this up to make it bigger for y'all. So you can see here that very simple menu, just applying a couple different sizes of the pizza, different crust types, different toppings, and then these are the prices associated to them. So then when we jump back to here, so we calculate the price, then we have this fake function that's estimating the timing. So I have a little bit of a, so as part of this API here, we had this helpers file that we had created, and you're welcome to review all this code, of course, that it's up on my GitHub. And then you can see specifically like that, basically I'm just estimating the timing very simply. So like, naturally, like if you've ever eaten like a Giordano's before, so their specialty is deep dish pizza, you're aware that the bake time is a lot longer. It's even longer than what we have here, but that's kind of the basic gist of like how we kind of set this here. So we are calculating the bake time, and then we are simulating what preparing and baking the pizza would be like behind the scenes with these helper functions. There's not really much there. It's actually just capturing some spans and OpenTelemetry stuff. It's actually not doing anything here in terms of real functionality. And again, that's not the point. We're just trying to learn OpenTelemetry. So, but trying to do it in a way that kind of seems real. Of course, this is not real. I'm not a pizza chef. I like to eat pizza, but I do not own my own restaurant, of course. And then finally, we have the persistence of the order. So in a real life context, this would be saving something like the order back to some sort of database. In our case, we're just saving to a very, very rudimentary Python list that is ephemeral. Ephemeral meaning that whenever we start up the API, we have an empty Python list that we continue to add stuff as the API is going. But if we shut down the API, then that list goes away entirely. Hence why you'd want a real database on the back end if you actually did something real there. So I think that kind of covers everything that I wanted to cover in terms of the last stream. And then just again, so you can see here with some of this code that I'm displaying on the screen right now, just demonstrating how we apply all of this in OpenTelemetry. I noticed some spacing there, a little mess up there, so I'll correct some of this as I'm going along. Probably some copy paste stuff that didn't copy and paste correctly, if I imagine. And then I guess this isn't super important for today's stream, but just being aware that whenever we accepted the pizza orders, and then when we get, so we would call that like the request, and then we want to return a response for the pizza orders. We're using actually up at the top here a Pydantic base model for each of those respective things. That way we have a specific structure on what we would expect coming in and what we would expect giving the response back to the customer. So that is basically everything that I want to cover from the last stream. So let's move into today's kind of stuff. So today we're going to take things a step further. So basically, just again, a quick recap, we have applied OpenTelemetry here to and instrumented our code appropriately. Now, if we review back here, the general definition of telemetry, like setting aside OpenTelemetry, I got this from Wikipedia. We can see that this general definition notes that telemetry is sending data to remote points. Remote points, I'm going to highlight that to make it clear right here, and their automatic transition to receiving equipment for monitoring. So the reason that this is important with OpenTelemetry is Technically speaking, yes, you can have your metrics, your spans, your anything else saved back to the same server in which the API or whatever application you are hosting. You can put it back on that same server. However, in most cases, you can imagine that we would actually want to send that telemetry from wherever we're hosting this application, whether it be an API or something else, and we would want to send that off to somewhere else. And so that's actually what we're going to cover today is how do we get the data from point A to point B? And I actually have a section on here on talking about getting the data from point A to point B. You're welcome to review this documentation on your own. And I will cover, of course, everything that is noted here. But what I want to jump into right now is I actually want to revisit this diagram right here. I started to touch on this diagram in the last stream, but I didn't necessarily understand it just because I hadn't reviewed it before. But now I do have a better understanding of it. And I think it does have a good, it helps us to kind of understand what we are trying to do here today. So off on the left side, with our microservices and our shared infrastructure here, imagine these are our software applications or maybe our infrastructure applications in which we want to capture that telemetry. So in our case, we are developing an API. You could consider that a microservice, and we are using the OTel Python SDK specifically to capture that all those traces, metrics, and logs there appropriately. And so that's what we covered as part of part one. Now, part two of today's stream is how do we actually get it to here? And what these would represent is so if you work in a big company, you might be familiar with vendor products such as Datadog, Dynatrace, Splunk to an extent, AWS CloudWatch. There's a bunch of different options that you can have here in which you can actually surface these the telemetry and make sense of it appropriately through like this, what they call the observability front ends here. And then we have this piece in the middle, the OTel collector. Now, in many instances, this OTel collector is bundled very closely alongside this right-hand part here. So, for example, so I'll just say today, because I am cheap, we are going to be using a free open source tool called SigNoz. And so we're actually going to locally host an instance of SigNoz and then send the telemetry from our Pizza API through the OTel collector to SigNoz. And SigNoz is, again, one of those things where we're bundling both of these things together. So we are bundling the collector and the observability backend together. In practice, it almost looks like these two things are the same thing. And I think that's why I got a little bit confused looking at the last stream is not recognizing that this can actually be its own entity. And you might be wondering, well, why would I want this to be its own entity? And that is because, again, so the reason that OpenTelemetry exists in the first place is we wanted a standard way to be able to send all of this telemetry to get to some downstream at the end here. So this OTel collector helps to standardize that thing. Helps to standardize the telemetry and then send it downstream to one or more layers if you want. So if you, for example, have something that is one or like let's say hypothetically, I don't think you'd ever do this in practice, but let's say you wanted to send your metrics and your logs to Datadog, and you wanted to send your traces to Dynatrace, you could do that. Now, again, most of those the two applications that I just mentioned there support all three of those OpenTelemetry signals. So in most cases, you're probably going to just end up using one. But if you ever need that as the option to send it to multiple downstream locations, you can do that through the OTel collector here. So I actually am going to demonstrate how to save out your telemetry two different ways. So I mentioned SigNoz already. And actually, so one thing I do want to highlight is, so right now I am streaming off of my MacBook Pro. And my MacBook Pro, you can't see it. It's actually sitting up here, up off to the right, my right here. In order to demonstrate, because remember, we're in most cases, we're sending data from one server to another. I'm actually going to host SigNoz on my Mac Mini, which is over across the room to my left, all the way over that way. So I'm actually SSH'd into my Mac Mini right now, and I'll demonstrate how we can set up SigNoz in a very simple way. Now, even though we are going to be setting up SigNoz and using SigNoz here, I actually don't know how many people are using SigNoz, so I'm not going to go deep necessarily into the ins and outs of SigNoz itself, but I still do want to show a basic way of how we can set that up. Okay. So that covers the concept of what we're going to do today. The rest of the stream is just going to be really just applying this and making it work for us. So as I mentioned before, let me close that down. So I'm actually SSH'd here into my Mac Mini, and you can see that per this this wording here. Again, I'm currently streaming off my MacBook Pro. And so in order to actually set up SigNoz, actually what we'll do, let me SigNoz GitHub. All right. So if you just do a Google search for SigNoz GitHub, it'll probably be the very first repo that comes up here. So this repo actually contains the code for actually deploying a local instance of SigNoz very easily. And we're actually going to use Docker here. So if you don't already have it set up, I would recommend that you install Docker. Again, I already have that set up. Most people already do, so we're not going to cover that as part of the stream, but it's pretty easy to set up. All you got to do really is just go to, I think, like docker.com and just download the respective installation for yourself, whether it's Windows or if you're on Mac. And then you can see here under this deploy directory, if we go down to deploy and then we go into Docker here, there's actually a Docker compose file. And so when we actually so if we just clone this repo and we navigate down into this specific directory, we can just simply run a Docker compose up command, and that's going to start up SigNoz for us. So I've already got SigNoz installed on my, or cloned to my Mac Mini. So if I go into my repos, I have it saved under my random, that's where I just put random repos. So you can see I've got SigNoz in here, cd SigNoz, and then, all right, so then it's, I think, yeah, deploy /docker, and then let's just do an ls to see that we've got the YAML files respectively here, respectively in here. So I'm going to do docker compose up, and then I'm going to do D. D stands for detached. That's as you can see, my little helper thing here is telling us that this just runs the containers in detached mode, and I will spin it down. The nice thing about SigNoz, though, is because we are running it locally, we're not incurring any cost at all. This is 100% free. It's just running on my local hardware. And again, you don't necessarily have to do the setup that I'm doing where I'm calling from one computer to another computer. You can do this all this that we're doing today on the same computer if you'd like. So I'm going to go ahead and run that, and it's going to take a couple seconds to start up here, and then we will continue on. So we'll give it just a second. Let me take a sip of my drink here. Okay. I thought it would be a little bit faster than this, but we'll give it a couple more seconds. It's not that long. Well, I guess I can talk about what we're actually going to be setting up kind of here. So with SigNoz, it actually does a couple things. So it exposes a user interface, and I'll share that user interface here in a minute. And then in addition, so the user interface, we're not going to cover that super in depth today, but you can do a lot of different things with the user interface. So for example, if you want to visualize your metrics over time, like number of HTTP calls or number of pizza order requests, you can do that directly from the user interface. And then in addition to the user interface, it's also exposing various endpoints that we can actually hook our application into. So that would be like the collector and such. One term I did fail to mention that now that I think about it is when we are actually sending, whenever we're packaging up this instrumented telemetry, we need to use an exporter, as I note here, to actually export that. Now, in our case, we're basically doing that with the Python OTel SDK here, so we don't have to worry about that too terribly much, conceptually speaking, because it's not that bad. Okay, so that is done. Now, so I'm on the same Wi-Fi network here, so with my Mac Mini from my MacBook Pro here. So if I wanted to view this, then I personally can just go to http David's Mac Mini local 8080. So this is running on port 8080 for me, and it should be the same for you as well, given that. So if I just do a cat out of this Docker compose YAML file, then you can, if you dig into here more, you can actually see the various ports. So you can see here that SigNoz is, at least the user interface is being hosted on port 8080. And then if you want to see the running Docker containers, then you just run docker ps. I can't remember what ps stands for. And then let me make this a little bit bigger so we can read this a little bit more easily. you can see that it spun up a number of different containers. So we actually do have the user interface being hosted on port 8080, and then the actual OTel collector, you can see here, is being hosted on the respective ports of 4317 and 4318. Now, the reason for this is you can actually interact with there's two different protocols for transmission of information to OTel. So there's gRPC, which stands for, I think, Google something something something. I don't know. I don't remember. This is the part where I'm a little bit hazy on this. So I think that one's running on 4317. And then you can also use HTTP, which I think is running on 4318. Now, for our cases today, we are going to be using gRPC. To be honest, I don't know a whole lot about the difference between the protocols. I asked ChatGPT about it, and ChatGPT basically said that gRPC is preferable, which is why we're going that way, but it is harder to debug. But however, we live in the age of AI coding tools, so I would imagine that debugging shouldn't be too bad. So that's why I'm sticking with this one. So now you can see here, this is the SigNoz UI. Now, the first time that you log in, you may actually see some sort of sign up kind of thing where it asks you for your email and to put in a password. That is not actually, just to be extra clear, that's not actually reaching out to any of SigNoz's servers or anything. And then if you put in your own email, it's not going to like send you any sort of email or anything. That's basically so like if we were to set this up as a production instance and like for a company and like we had like, you know, multiple users, 10 plus, 50 plus, 100 plus users, then you'd want to have their own respective logins. That way within the SigNoz UI, you could lock down certain things, assuming that, you know, traces can be sensitive, of course, so we wouldn't want just anybody viewing that. So when you do sign up, it will ask you for the, perhaps ask you for that email and password. Just put in whatever you want there. It doesn't really matter. So you can see I'm already logged in though. And if I were to just go into things off on the left nav here, like looking at our logs, we shouldn't really see anything yet. Naturally, no logs yet, and then same for the traces, and then same for the metrics. Now, this is going to start to change once we start to actually hook everything up with our pizza order taker here. So nothing here quite yet. This is all just default. All these metrics that we're looking at are just defaults that come with SigNoz here specifically. Now, I mentioned, okay, sorry about that. Let me change my thought process here. So let's come back into our code here. This actual pizza API code that we've already written, we don't have to adjust any of this at all. And the reason that we don't have to adjust any of this at all is we already covered this part at least, where we have the OTel config, that is just being referenced from this other file called OTel config py. And this is the primary file that we're going to be working out of. So we don't have to touch anything within this API script here. So I just want to highlight that out here. So even though basically from here, we're importing it, and then we scroll on down and you can see that we instantiate it with this function that we've created. And so it's all being pulled from here. Now you can see that this file is empty. I did have it populated earlier today, but I purposely wiped it out so that way we could start fresh. And again, recall that I am setting this up in such a way that I'm going to save all of our telemetry to a local file, which in most cases is not preferable, but I'm just going to show it just to show it. It's actually a little bit tricky to get that set up, but we'll demonstrate that anyway. And then we will demonstrate how we can actually send this telemetry to SigNoz within this exact same Python script. Okay, so let me change to my other view here on my bottom screen so that way I can reference the code. We have a lot of stuff we're going to import today, a lot of stuff. So first off, we're going to just do importing standard Python libraries. So we got a couple of standard things that we need to make use of. So we're going to do from future import annotations from OS. Oops, I'm sorry. Import OS from pathlib import path. Now we need to importing general OTel libraries. So these are some general libraries that general things that we need to import. So we're going to do from OpenTelemetry import metrics and trace. From OpenTelemetry.sdk.resources. I'm going to import a resource. Forgot to put the S there. There we go. Now we need to import importing OTel trace things. Things is a technical term. Not actually, I'm just being an idiot. All right, so let's import all the stuff that we need for traces. We need from OpenTelemetry.sdk.trace, import trace provider. So this is going to be where we're actually sending our traces. This is going to help facilitate we're actually going to send our traces to. We're going to do from OpenTelemetry.sdk.trace.export import. Going to do a couple of different imports here. We're going to do batch span, simple span, and span exporter, and then span or export result, span export result. So all of those. Sorry, just was having a hard time looking at that on my screen. Oop, gotta scroll over again. And then we need to move from OpenTelemetry.exporter.OTLP. Oh, I guess that is one thing I do want to touch on really quickly because this is going to get really confusing. There is a difference between OTLP and OLTP. I can't remember what OLTP stands for, but basically you might be familiar with OLTP and OLAP as like different mechanisms for interacting with databases. So OTLP would be like SQL data, like SQL databases like MySQL or Postgres, where we're doing transactional kind of interactions, and then OLAP is for analytical stuff. So that is something different. It's not OLTP, it's OTLP, and that stands for OTel. I can't remember. Yeah, OTel protocol. OTL stands for OTel, and then P stands for protocol here. So just so you're not screwing that up, because I got a little bit hazy on that for a second. So .proto. .grpc .trace exporter import OTLP span exporter. All right, so that covers the imports for traces. So let's importing OTel metrics things. So now we're going to do stuff for the metrics from OpenTelemetry .sdk.metrics import meter provider. Most of this code, like, it's actually funny, I'm reading this now. Yeah, like a solid like 25% of the code is just imports. So if that tells you anything. So yeah, all right, so from OpenTelemetry.sdk.metrics export, we're going to import a number of things, and I'm just going to put them all in separate lines to help with readability. Metric exporter, metric export result, metrics data, and periodic exporting meter reader. All right, and then we're going to do from OpenTelemetry.exporter .otlp.proto.grpc .meter exporter import OTLP meter exporter. All right, so that covers our OTel metrics things. Now we got one more signal to cover. That's our logs. So importing OTel logs things. And more. So we got a couple things we need to import here. So we need from OpenTelemetry _logs import set logger provider. All right, and then we're going to do from OpenTelemetry .sdk _logs import logger provider, logging handler, readable log record. And then we got a couple of more things we need to import in from OpenTelemetry .sdk .logs _logs, my apologies, .export import. And then we're going to do another multi-line thing. So we're going to do batch log record processor log record exporter export result, my apologies. And oh, we didn't need the exporter anyway. Log exporter. Okay, and then one more thing here. We need to account for our gRPC thing again. So from OpenTelemetry dot exporter dot OTLP dot grpc Oh, proto. That's why. Okay, I was wondering why it wasn't syntax highlighting that correctly. Thank goodness for syntax highlighters. grpc dot log exporter import OTLP log exporter. Okay, so that covers all of that. Now let's do some simple setup before and then we're going to create a couple of helper functions, and the helper functions and helper classes are going to help specifically with that the local output. And in fact, actually, it looks like I don't know how that showed up. I meant to have that whole thing deleted. All right. Anyway, okay, so let's set up a couple different things here. So we're gonna we're gonna call the service name. Service name is going to be pizza OTel demo. Okay, and then we are going to set. We're actually gonna be making use of a shell script to kind of set some of the stuff up. And so the reason that we're gonna use the shell script is because the shell script, as we noted, we're gonna be able to use this exact same OTel config Python file here to either send our logs locally or send them to OpenTelemetry. So we're actually going to use environment variables here, and we're going to set the environment variables from the shell scripts that we're actually building to actually make that determination here. So we're actually going to just read those in. So we're going to say OTel collector endpoint equals os.environ.get, and that's going to be OTel exporter OTLP endpoint as such, and then we're gonna set this default export target as OTLP, and then we are also going to do default default local exporter equals telemetry output. Now you might be wondering, well, what is this thing down here? So this might make sense. So we're saying we want to have things sent out through the OTLP protocol. So we don't necessarily have to worry about that too much. And then what this is doing is you actually, well, why does this keep showing back up? That is weird. I wonder if there's something going on wrong with my code. But anyway, so we're basically saving the local files out to this telemetry output directory, and it's bugging me that it keeps recreating itself. I'm not sure what's going on there. Okay, so there's that. Now let's create a little helper function. So when we save out the telemetry to local files, we're going to actually save them out as JSON-L files, JSON line files. So we're actually going to need a little helper function that actually continuously adds new things to that helper file. So we're just gonna call this function def append line. Now, if you're wondering what is the underscore in front of here, that is just a Python nomenclature to denote that, like, this is like an internal function, meaning that it's not this function is not intended to be used like by any other like outside party, if you will. So that's why that underscore is there. So we're gonna do file path. File path is a string. I need to put on my glasses. All right. Glasses on. All right, file path. Oh, I didn't mean to say string. I meant to say path. And then we're going to have a line that's going to be a string. And then it's going to produce nothing. This is just kind of a thing that's, the function itself is not producing anything. We're writing to a local file, actually. So we're going to say creating the directory if it doesn't already exist. And so this is going to be file path dot parent dot make dir parents equals true. Now you might be wondering, well, what is this parents thing? The reason it's like, so when we actually invoke this script, we're invoking it from the src directory, the source directory here. So I actually want it saved, the output saved to this directory that's adjacent to the source directory. That's why we got to go up one. Okay, so lost my parents equals true. All right, exist okay equals true. So that's basically saying if it already exists, no need to recreate or anything. And then updating the local files with new telemetry. So this is basically just writing the telemetry out. So we're going to say with file path dot open. We're going to say I can't remember what A stands for. Encoding equals UTF-8 as output file, and then we're going to say output file dot write. We're going to write that line that we're accepting as an input, and then we're going to write a new line character. Output file dot write a new line character just to start a new line. Okay, so that is just a simple helper function to help us out here. Now, the next couple of we're actually going to create a couple of classes, and these classes are basically making use of the spans export, the trace exporter, the metric exporter, and the log exporter appropriately to kind of do our own custom version of how do we actually implement this thing to actually write things out to a local file. This now, in most cases, whenever you're actually interacting with like a Datadog or a Dynatrace or a SigNoz in this case, we don't need to go with all this custom code. And I even kind of debated if I even wanted to do this because this looks way more complex than it actually is. But in real practice, you're probably not going to be doing this. I just wanted to do this to demonstrate two different locations in which we could send our telemetry. All right, so our first one, we're going to create the class that actually updates our JSON line file for logs specifically. So we're going to say class JSON line log exporter. And so we're going to inherit from the log exporter, the log record exporter. So we need to do a couple different things. Of course, we need an init function. We're going to pass in ourself, and then we're going to pass in the file path as path. We're not going to return anything though. So we're gonna initialize from the parent class here. The parent class here is going to be this log record exporters, which is provided to us through the OTel Python SDK. And then we're going to say self dot file path equals file path. Okay, so that covers our init function. Now we need to define an export function. So def export. So we're going to take in ourself, of course. We're going to say a batch. We're going to pass in a batch of stuff, and it's going to be a list of readable record logs. Readable record logs. Say that 5 times fast. All right, and then we're going to return a log record export result. And then we need to iterate over each of the respective log records in that batch. So we're going to say for log record in batch. And then we're going to use our handy dandy helper function that we just defined above. So we're going to say self.filePath and then log record and then line. No, we'll just keep going. So log record dot to JSON. All right. And then we are going to return success. Return log record export result dot success. Okay. And then finally, one more thing, we need to handle the shutdown. And for shutdown, we're not going to really worried about anything but shutdown. So we're not going to return anything. I think, so just to be completely transparent, I had AI help me write this code. What I imagine what's going on here is that like when you inherit something like this and you're doing your own custom kind of implementation, that you have to account for a couple of these different things. So I imagine this is just one of these things that you have to account for even if you actually do nothing with it. So in this case, we're going to just say return none. Okay, so that covers the log export for local files. Now we need to do the 2 more classes, very similar. So our next one is going to be our metrics. So we're going to say class JSON metrics exporter, metric exporter. So we're inheriting from that parent level class. So we need to do an init function, self file path. File underscore path. It's going to be a path, and then we're going to take in additional keyword arguments, and then we're going to produce nothing, but we're going to inherit everything, and we're going to pass in the keyword arguments to our this metrics exporter parent level class. Again, this is, so what we're actually covering is, I don't want to say advanced Python stuff, but I would say it's kind of intermediate Python stuff. If you're not familiar with inheritance, this is not exclusive to Python. Like pretty much every form of modern programming language has some form of inheritance. I actually learned inheritance through Java. Actually, so this is a bit of an aside, kind of a fun fact. I actually started off my coding journey learning Java, and I actually went so far to become Java SE8 certified. And I don't know if that certification still exists, but oh my gosh, that was by far the hardest certification I have ever taken. I passed by the skin of my teeth. Basically, like what they do is they give you this massive JavaScript, not JavaScript script, Java space script, and have you go through this whole thing and then find what was wrong with it. And it may have been something as simple as like a semicolon was out of place. And my wife likes to make fun of me because if they take a picture of you before you take that exam, and I just look, or maybe it's probably right after I take the exam, because if you look at my picture on my certification, it literally looks like a mugshot photo. Because I was just so trained after that. I was just like, I'm not smiling for this stupid picture. I'm just happy I passed. Anyway, so self.file path equals file path. Man, that was such a hard certification. I'm so glad that I passed it on the first try, though. All right, def export. So we're going to take in our self metrics data. It's going to be the type of metrics data. Metrics data. Thank you, syntax highlighter. Okay, so then we're going to do timeout milliseconds. So we're going to set a default float value equals 10,000 milliseconds, and then we're going to take in the keyword arg. Oh, my face is starting to get in the way. Let me move my face out of the way for y'all, so that way you can see the code. We're going to take in the keyword arguments quargs, and then we're going to produce none, and then this is actually going to be, oh, no. I'm sorry. I'm reading the wrong thing. It's not none. It is metric export result. And then we can start to write some of this other stuff here. So we're actually going to, again, make use of our handy dandy helper function. We're going to send it the file path, and then the line is going to be the metrics data dot to JSON. All right. And then we need to kind of do something similar to what we did in the previous class before. So we needed to define this shutdown function, shutdown self time out float. It's going to be, we're just going to set it to a default of 30,000 for this one. And then this is going to be none. And then we're going to return none. And then we need to do one more thing for the metrics at least. We need to define a force flush. Force flush, to be honest, I don't know what a force flush is. I didn't mean to do that. This whole thing here. We're actually just going to return true. It's going to produce a Boolean, but I'm actually okay with the rest of this, I think. I do want to make sure that this is a float. Float, and then we're going to produce a Boolean value. Bool. I'm just going to return true here. Okay, so did I miss one? Did I skip past one? I did skip past one. Okay, I did the logs and I did the metrics. I forgot to do one for the spans. All right, so let's make a, I guess I could have done it below, but it doesn't matter. I'm going to put this up here. I'm going to put class JSON line span exporter. I just realized I forgot to put the ER there. Did I forget to put the ER there here as well? Metrics exporter. Okay, sorry about that. All right, next, or tur, not turt. We're going to inherit from the span exporter class. Do a definite self file path, and then we're going to produce nothing here in the end. All right, just checking for questions or anything. All right, we're still good. Self dot file path equals file path, and then oh, that would be why. Syntax highlighting really saving the day here. All right, def export self spans. And then we're going to produce a span or export result. Span. Oh my gosh, if I can type right, span export result. And then we are going to say for span in spans. You can guess what's coming next. We're going to use our helper function once more, self.filepath. And then we're going to pass in the span.to JSON. And then we're going to return span export result dot success. All right, just a couple more things, and then we'll have this part done. Def shutdown self none return none. Okay. Now, because we just did a lot of typing there, I do want to do a quick recap of what we did. So basically, we just did an import of all the different imports that we're going to be using here. Then, because we're going to be using this OTel config to send things to both SigNoz and locally, we have to do a bunch of stuff to set up the local stuff. So that's what this is all doing, where we set up our helper function, the append line, and the append line is going to be used across our respective JSON line exporters. These three for spans, logs, and metrics. And then we will continue on now by actually demonstrating how we can actually apply this appropriately. So now recall back in our pizza API file that we are importing configure OTel from this OTel configuration file. So and then actually invoking it down here further on in the script. So now let's actually build that function. So we're going to say def configure OTel, and we're going to actually return nothing, formally speaking, from this Python file, because we're actually going to be set. Even though this is a little bit of a misnomer, because the function itself is actually going to return nothing. However, we're actually going to be setting up things that we've actually set up here. So we like this tracer or this meter or this get logger. This is all going to be set up as part of that configuration here. It's just that we don't necessarily have to directly return them in the Pythonic sense, if that makes any sense. All right, so let's first set up our resource. Our resource is going to be resource equals resource.create, and then we're going to say service.name is going to be our service name, which we defined up above. Next up, we need to, so I actually did this for my own sake. So recall that as part of the previous stream that we did a PyTest unit testing script for it. Now, for PyTest, I personally don't care to test out the OTel piece. Like if I was writing unit tests, I would be more, I don't know. This is actually going to depend on what you want to do. But for our case, we're actually going to create this variable called running under PyTest, which basically will say, like, if we're running this under PyTest, then don't like set any, like, basically disable OTel. So that's what this is kind of doing here. This is just going to depend on what your preference is. All right, now we're going to set our export target. Export target equals, so we're actually going to do this thing where we're going to either read it as an environment variable, or set the default one. Yeah, so we're going to do get OTel export target, or we're going to default down to the default export target dot strip dot lower. Okay. Next, we're going to set the local export directory. Local export directory equals path os.environ.get. So we're going to say OTel local export dir, or we're going to just use the default one, default local export directory, and then we are going to do an expand user on this dot expand user. Okay. next, we're actually going to set the specific like file paths for, because we're going to save traces to one, metrics to another, and logs to another local file. So we're just going to set these up appropriately. So we're going to say traces file equals local exporter slash traces.jsonl, because we're saving these out as JSONL files. So metrics file is going to be same idea, local exporter slash metrics JSONL, and then finally we got our logs file, local dot export. Local exporter underscore is there, and then we're going to say logs.jsonl. All right, so now that we've set all that up, let's go ahead and set up our respective providers. So our providers are basically going to be basically in the OTel sense saying for each of the respective signals, where should we be sending these to? And so, well, let's go ahead and write out the code, and then we'll talk about like kind of what it's doing. So we're going to say defining the trace provider. So we're going to say tracer provider equals trace provider resource equals resource. Wow, we've already almost gone an hour, and I legitimately thought we were only going to go 30 minutes. So there we go. Exactly what I was talking about. Like, but I mean, again, I'm writing all this out by hand just to kind of drive things home. But I could have just copied and pasted this all, and then we would have been done like, I don't know, 30 minutes ago. If not running under PyTest, so if we are not doing a PyTest, so we're going to check our export target. So our export target here is going to, like, again, because we're going to be using shell scripts to kind of start everything up and then determine, are we sending this to SigNoz? Are we sending our telemetry to just a local file? That's what this next piece is going to be doing. So if export target equals file, so this is our local path, equals file, then we want to say tracer provider dot add span processor. This is going to be a simple span processor, and this is going to make use of our JSON line exporter, and then we need to put and then we're going to pass in as our file path our traces file. Okay. So I hope that kind of makes sense there. So that sets it up for local. Now, if we want to do else, so we're going to do else. So this is going to be our SigNoz provider. So tracer provider dot add span processor. I'm going to do this on a new line just for readability purposes. So we're going to say batch span processor OTLP span exporter. And then we're going to set the endpoint to be the OTel collect endpoint equals OTel collector endpoint. Now, this is going to be coming from the environment variable, which again will come through the shell script, which we'll cover that here in a little bit. All right, so that covers the tracer provider. And then we need to do, come on. All right, there we go. Trace dot set trace provider tracer provider. All right, that is setting up the provider for traces. Now let's move on to metrics. Defining the metrics provider. It's going to be a similar kind of thing. So we're going to say metrics, metric readers, instantiating that as an empty list. If not running under PyTest, so that's just accounting for my PyTest thing. If export target equals file, then we are going to do metric readers dot append. We're going to say periodic exporting metric reader, and then we're going to say JSON metrics exporter. So this is our custom one. So this is covering specifically the local writing of the files here. And then we're going to say export interval milliseconds. We're going to say it's going to be 2000. Okay, and I think that covers local. Okay, so else metric readers dot append periodic exporting metric reader. And then this time, this is going to be for SigNoz, so we're going to say OTLP metric exporter endpoint equals the OTel collector endpoint. And then we're going to say the interval is going to be 5,000 milliseconds this time. Export interval milliseconds is going to be 5,000. Okay, that covers that. Now, metric provider equals meter provider. We're going to say resource equals resource. And we're going to say metric readers equals metric readers. Okay, meter provider. Now we're going to say metrics dot set meter provider equal, and then we're, well, not equals, but we're going to pass in meter provider here. Okay. Metric provider. My apologies. Not. Well, I meant to put this as a meter provider. There we go. My apologies. Okay, so that is setting the meter provider. Now we need to set the log provider. So a lot of this is just a lot of like setting up of stuff. As you can see, we're actually getting pretty close to the end. So let's say setting up the log provider. And I hope you're getting an appreciation of how OTel works here. Especially, I'm going to pause here for a second because I want to highlight again, when we're setting up this backend of where this telemetry is supposed to go, we actually don't have to update anything of this file here, given that we already use OpenTelemetry to set up everything. So the really nice thing here is, so we're sending to a local file, or we're sending to SigNoz. Let's say that I had set up like Datadog or Dynatrace or something like that, and I wanted to send it off to somewhere else. No problem. I don't have to update anything in here. I just have to do a couple of relatively minor updates in this file over here to make it work with some other sort of collector or some other sort of backend source. So that's the beauty of OTel and the reason why OTel exists. So we're going to say logger provider equals logger provider, resource equals resource. All right, if not running under PyTest, if export target equals file, then we're going to say a logger provider dot add log record processor is going to be batch log record processor JSON. All right, so here comes our custom log exporter. Oops, log exporter, and then we need to pass in the logs file here. Logs file. All right. So that is setting up our local writing of the logs. Now we're going to go and set up what do we got to do for SigNoz. What we have to do for SigNoz is logger provider dot add log record processor, and then we're going to do a new line here. So we're going to say batch log record processor OTLP log exporter, and then we're going to pass in the endpoint equals OTel collector endpoint. Okay, and then we are going to set the logger provider. Set logger provider. Provider is logger provider. All right, and then we just need to set up a couple other things for the logger here. So we're going to say handler equals logging handler. All right, so this is defining the kind of logs that we want to capture here. So we're going to say what level of logs do we want. We want to capture our info-based logs with the logger provider. Logger provider equals logger provider. Logging.info. Why are we getting a little bit of a squiggly line there? Did I not import something? Oh yeah, I forgot to import logging up here. Import logging. Missed one import. Not too bad. Okay. And then, all right, lost my place in my code here. I need to get a kind of a better setup because I don't know if you're noticing this. So just a little bit behind the scenes. So I have the camera off to the left here while I'm looking directly at my screens. And so what you are looking at on your screen right now is my top monitor. And then I have a bottom monitor that I reference for like, so over here I've got Streamlabs set up, which is like the streaming software that I use. Over off on the right, I have the thing that's monitoring the chat for questions. And then in the middle here, I have the actual code that I'm referencing. And I don't know if you could tell, the code is behind my microphone here. So that's why I'm doing this weird lean over thing, because I can't see the code very well. And it's that little bit behind the scenes there. All right, app logger equals logging.get logger. I'm going to call this pizza API. And we're going to say app logger.set level logging.info. Okay, we're going to say app logger.handlers.clear app logger.add handler app logger.propagate equals false, and then if not running under PyTest and export target is file, and we're going to say app logger.info open our message that we're going to log out here is OpenTelemetry export configured for local files, and then extra equals telemetry dir, and that's going to be a string represented by the local export directory .resolve. Okay, that should be everything. I'm not seeing any other syntax highlighting issues here, so we actually should be good to go ahead and test this all out. Oh, I am getting some sort of red here. Where is this red coming from? Else dot. Did I not do something here? Let me check my reference code here. Dot append periodic metric readers. Dot append periodic metric reader. Oh, looks like I just forgot a comma here. That might be it. Okay, now the red went away. All right, now let's actually go ahead and demonstrate how we can invoke these things. So I actually went ahead in my GitHub repo. I went ahead and had my AI coding tools. Sorry about that. We got a couple different shell scripts here. So we have two shell scripts. We have one called run local test and another one called run SigNoz test. I actually, like I said, I had AI write this for me. So I'm not going to rewrite any of this stuff because I'm ready to get back outside. And I'm sure you all are ready to be done with the stream as well, since conceptually speaking, relatively simple what we're doing here. So but I do want to kind of walk through what this shell script is doing. So first things first is I am setting to navigate to the root of the repository to make sure that like we have a consistent starting point for this shell script, if you will. Then we have just some like color setting for just better readability. We're noting our API that we are actually going to be making use of. So recall we're using the source directory. We have our pizza API file with the pizza API, fast API instance inside of it. Then here we're actually setting the target where we actually want to send things. So you can see here that because this is the local thing, we're setting our local input is going to be a file where we actually want to save our local exports. And then this thing here that says OTel disabled. So if you ever want to disable OTel, it's actually pretty simple. You would just actually flip this OTel SDK disabled to true, and then your collection of or your export of your telemetry would be stopped. This is just noting some of my like my Python virtual environment stuff. We don't necessarily need to worry about that too much here. Then this is just some extra code that, because what we're doing here is we're actually starting up that fast API instance, hitting it with a couple of different fake orders, and then shutting it down. But I added a cleanup thing that way, just in case, like, for some reason, like, the API was still lingering around after the fact, and that's what this cleanup thing here is doing. And then more cleanup kind of things. Now, this next part here, this is all a lot of just cleanup stuff. A lot of just echoing out of like the various things that we started above. Now this is where actually the kind of the code starts here, where we are actually, so this is actually using Uvicorn here, and then setting up the specific OTel Python, or I'm sorry, the OTel environment variables that we are reading back into Python. So if you recall, like the export target here, we actually are making use of that here with, where's an example? Yeah, like the export target right here would be file. So that's what is noting here. And it actually starts up the Python fast API, doing a little bit of a sleep thing here, just curling to make sure that we can actually hit the some of the get endpoints. And then here is actually where we are invoking the API with all our different orders. So if we come back into here under our test directory with our sample data, we have a bunch of different fake orders here. I think 10 different fake orders that we're basically just reading in, and then we are hitting that order endpoint, and then this is where it's actually noting where all the respective traces and stuff should go. So that's what this file is doing. Now the other one, very, very, very similar, except obviously we need to update some stuff for SigNoz. So what I wanted to call out here for SigNoz is, so we are sending stuff to port 4317 because that is the gRPC port. I'm trying to find where my actual, here, let me just do a search here, David. Okay, so this is actually noting specifically, so this, so if you're not familiar with how Macs kind of work, like typically speaking, you would use like an IP address that you would need to reference. However, there's this thing called like Bonjour. I don't really know what Bonjour is, but it's basically a way to set like a friendly name for the for instead of an IP address for Macs. So that way I can actually set this and safely still safely hit my Mac Mini, which is sitting across the room, but not within this shell file here. It is not exposing my IP address directly. That's just using the friendly name. But otherwise, pretty much everything else in here is going to be very similar. Yeah. Well, you might notice that we are setting a couple of extra environment variables, noting that we are passing everything with the gRPC transmit protocol there. But everything else here is pretty much the exact same. So let's actually demonstrate this in practice with the actual code. So I'm going to clear this out here, and then I'm going to go to cd test/shell scripts in there, so you can see both of those. Now let's go ahead and do, again, I don't know why this keeps showing back up. This should not be showing up. There must be some minor hacky bug going on. But if we do a bash run local test, so we'll see this kind of in action. So has no, okay. Well, I must have done something wrong. I probably have some minor syntax error in here. So what I'm going to do is I'm going to kind of cheat here really quick. And I'm just going to, what I just did there super quickly is I copied and pasted all of my reference code because I know the reference code works. All right, so let's try that again now. So let's try that. And so we should see us starting up. So you can see here that we just invoked the telemetry, and then it saved everything out to the local files. So now if we review the local files here, you can see we got 3 respective JSON-L files. Our JSON-L file, so these are all of our logs here. This is all saved within the OpenTelemetry format. If we wanted to look at our metrics here, we could look at all of our various metrics that we were wanting to capture. So you can, I want to find at least one of these. So if I continue scrolling down, I would probably find, okay, so you can see here, pizza.revenue, total pizza.revenue in US dollars. So you can see that we set a couple different attributes here, and then we finally can see the appropriate values here of like 25 and such. And then finally with our traces, same idea. we can review all of the traces that we would have captured that we have instrumented as part of our code here. So that is how we actually do everything within local files. Now, if we want to do the same idea, we'll just do, but with SigNoz. So we're going to do bash run SigNoz test. Now, so we just hit everything. Our whole shell script just ran, but this time it sent everything to SigNoz, which is the reason I'm pointing over there is because my Mac Mini is sitting across the room and it is making use of that SigNoz instance. So now if we go into here, recall before there was no logs. Now we got a bunch of logs populated in here. Or if we wanted to look at the traces, we could look at, looks like we might have had an issue with the traces there. Yeah, I'm not sure what happened there. It was working for me before. And then same idea with the metrics. What happened to our metrics? Our metrics were populating in here for me before, but now they don't appear to be. Did I not run the right thing? Let's try to run this again. Bash run SigNoz test. Let me check this again. Okay, I don't know if SigNoz is having an issue because this was working for me just fine this morning. Our logs are still coming in. Our traces are not. Is there any indication of why? Okay, I'm not sure why they're not showing up. And to be honest, I don't know how much I care. Because I know it was working before. It's probably some simple little thing that is... Let me check here. Docker PS. Is everything running still correctly? Let me actually take this down and see if I can bring it back up. Compose down. All right, it's going to stop it, and then I'm going to restart it and try to run it again and see what happens. I promise you it was working before. It's actually kind of a miracle that I've done so many of these streams now, and I don't have more live demo issues than I have had in the past. Like, it's kind of rare for me to have live demo issues, but that's because I thoroughly test everything before I do one of these streams. Now, I'm really not... I'm less familiar with SigNoz, which is why I'm not super worried about it. And I personally, like at work and stuff, I don't use SigNoz, so I probably will never use SigNoz again after this. The only reason I did it is because I'm cheap and didn't want to pay for anything else, and just went with a free option. Which is not to say that this is a bad product by any means. Like, actually, if anything, it's actually a pretty slick little product for being open source. So appreciate it for what it is. All right, we'll give it I can't remember how long it took this last time for it to set up. Did it tell us last time? Oh, it took about a minute. Okay, we're already at 47 seconds, so let's give a couple more seconds. We are at the very tail end of the stream, though. We're going to wrap things up right after this. I guess one thing I could demonstrate as well is because this is OpenTelemetry, you can actually look at like other open source kinds of products or like other products that you leverage to see like, can I actually capture my own telemetry? And the answer is yes. So like, for example, well, this already started up. Let me get back to that in a minute. So let's run this SigNoz test again. Okay, so that time it ran everything. So let me refresh. No traces, but okay, the logs are still coming in. The traces are not, and neither are the metrics. Okay, I really don't know what happened this last time. It was working though. I promise you it was working. Okay, so anyway, I think I am going to call it here though, because I could probably spend another hour or so trying to debug that error, but it's neither here nor there. I think it's probably just some simple little thing that got screwy there. That is all I wanted to cover for this stream. Oh, that's what I was talking about. So on my Mac Mini, I have Codex running, like the OpenAI Codex utility. And so actually, if you want to use OpenTelemetry with Codex, then so like if here, let me go back to my source directory, cd to tilde, then let's go into cd.codecs. And then under .codecs, you should see, where is it at? The config.toml file there. So let's cat that out just to show you config.toml. So in this config.toml file, you can see that I have asked codecs to send any of my logs and stuff to OpenTelemetry, or I'm sorry, to SigNoz specifically. Yeah, ignore this latter part. I guess that was added after the fact. But anyway, so now that I have that in place, like let's say I went to this repo. So cd, well, do I even have it on here? Cd OTel tutorial. Let's pull down the latest changes. Origin main. And this is kind of beside the fact. Like, I'm going to clear all that out. So if I went to codecs, and I would say, do I trust the contents of this directory? Yes. Explain at a high level what this repo is doing. Then it's going to function just like codecs does, but what I want to show here is what's kind of cool is if you, for whatever reason, wanted to capture your own metric, if you wanted to capture your own telemetry from codecs in your own instance or whatever, then we're actually having some of that piped into SigNoz here. Now, codecs does not support all three forms of signals. I think it only supports one of them. So we'll be able to see that here in a minute, though. So let's just let it continue doing its thing for now. I think it's getting pretty close to being done. Okay, I think that's done. So now if I go back into SigNoz here and I go into my logs, then you can see we got a bunch of different of these little logs here. And then if I were to go and look at any of the JSON associated with these logs, then you could see this is actually codecs in action here. So kind of cool. So if you, I believe Claude Code also supports this. So yeah, if you ever have a desire to send your own telemetry to your own local instance or off to Dynatrace or something like that, you can do that relatively simply. Okay. That is all I want to cover today. So that is OpenTelemetry. So we're actually going to complete OpenTelemetry here. With our next stream, we're going to move on to something new. Not really sure exactly what that new thing is quite yet. I am starting to do a 2026 evaluation of MLflow. If you've followed me for a long time, we've never actually done anything stream-wise with MLflow, but I do have a couple of older blog posts out there for MLflow for the traditional AI side of things. But now I'm doing an evaluation of MLflow, kind of revisiting that here in 2026 because I think that was like 2022, and they've also added a bunch of new stuff for generative AI that I kind of want to cover as well. So MLflow will probably be our next miniature series. It might be a 1 or 2-parter or 3-parter. I'm not sure quite yet. But anyway, I am going to go back outside and enjoy the sunshine. And ooh, my hair's all messed up. So I hope you enjoyed the stream. I hope you got something out of it. And I will see you in the next one. Have a good day, y'all.